Oh, you haven't
And
started.
now
Oh, you
we're
just never
rolling.
started recording.
So Beagle started.
Oh, okay. So I was a co-op for Texas Instruments starting back in '92. In 2007 is when I started hacking on this Beagle idea. So it's been going for about 11 years now, and it was. Well, I'll get into kind of my motivations behind it, but it's been the best kind of thing I could ever do, right? I mean, I have the dream job, right? But like ideally for me is I would enable other people to either do what I do because I think it's so awesome, or to do otherwise what they want to do with computers, right? And all the things that computers can do, right? Because it's controlling the physical world, processing data, all the amazing things that computers can help automate for us so that we can do the fun stuff. And it's been a fantastic journey, right? I've had a lot of fun. When Beagle's going to space, it's not news, right? Because, of course, it's always cool when we get more people sending them up there. But we've had Beagles in space since like 2010, I think, or so. The original Beagle board was put into space. There's Beaglebone Blacks up there now. But what I really get excited is about when people bring things back down to earth and really make them accessible for people. So this is another project right here, the Open ROV, which these guys' story is really great because they lost their jobs, right? And we're trying to look for, their actual goal was to try to find buried treasure in an underwater sea cave. And so they went to their local hackerspace and started experimenting with different technologies. They ended up taking Beaglebone Blacks and building this open source underwater exploration vehicle. They never found any gold in the cave, but they started a company, Open ROV, and now they have a company where they make underwater exploration vehicles, right?
Is that related to Blue ROV?
I don't think so.
Open ROV.
Open ROV.
But this is one of their prototypes on screen?
Yes.
Okay.
Yeah, that's yeah. Yep. That's their kit. That's an open source kit model that they sell. They learned these things by working with the community that was at their local hackerspace, right? And so, kick around like discovering buried treasure, and they ended up discovering a new career, right? And building a business. We've inspired a lot of people to go and write books. There are over 50 books out there on Beaglebone. That's awesome. Lots of these are in different projects, sort of things, home security, automation things, building robots. Fantastic. Another way that people share back into the community is providing add-on hardware. So we've had a lot of people build these Cape add-on boards. So there's hundreds of them out there that you can find designs for. People have augmented the capability of a Beaglebone Black. One of those being the robotics cape that we'll talk about in here. It was built by a students out at University of California, San Diego.
Is CAPE short for capability?
It is. So it's a.
Physically, I'm familiar with what it is.
Yeah.
It stacks on top and then it adds some.
So Underdog is a beagle. I don't know if you realize that, but Underdog is a beagle, and Underdog wears a cape.
Oh, okay.
So it's pretty much a nod to Underdog. The shape, also with the Ethernet cutout, looks a lot like a cape, right? If you look at a lot of these ones up here and some of the other ones, right, it has this little, they generally have this shape where it looks like it's got the little things coming up over the shoulder and then got the rounded drape at the bottom. So wearing capes. personally, I just call them daughter boards, and it's just fine with me. But everybody seems to have a cute name. At the time, people kept calling them shields, and it's like, well, they're not shields because shields are for Arduinos. So call it something else, and call it a cape. And then everybody else did something. Then after that came, I know Raspberry Pi, I think, calls them hats. But remember, they copy us. We didn't copy them. And that's been pretty much consistently true. In fact, Eben was like originally quoted as like, what is this Raspberry Pi thing? It's like, oh, it's like a Beaglebone but cheaper. It's like, okay. Anyway, I'll try to keep my sour grapes to myself. So what really excites me though, so you've got books, you got people sharing hardware, is people getting, ready for careers, right? Because ultimately, all right, well, like I said, I want people to actually be able to do the job that I do, and be able to create the career path that I've created for myself. And so we work with folks like the Linux Foundation. The Linux Foundation, their trainings are based on Beaglebone. And now we've been working with them on these embedded apprentice Linux engineer courses, where going to trade shows and getting kind of teaser trainings for those deeper embedded Linux trainings that they provide. But the teaser training is a week-long training. We'll be stealing a bunch of the slides on this EL program, but people learning how to actually develop in the Linux kernel. And the fantastic thing about developing in Linux kernel is it's single maintains source, right? It's one set of code that is Linux, but anybody can contribute to it. And that's really, really important because there's a lot of different ways to develop software and a lot of different software choices. And I'm going to reinforce that if there's a way to do it in the kernel, doing it in the kernel and submitting it to the kernel source repo is going to be the best way to do it. With enough eyes, to channel Eric S. Raymond, with enough eyes, all bugs are shallow. So the idea of everybody sharing this one code base, everybody's going to be impacted if there's a bug, everybody's going to want to try to fix those bugs. If you get your code in there, it's going to get fixed. If you pick some random Python user space library off of somebody's website, all bets are off, right? I mean, it may work for you, it may not, but the longevity, the ability to maintain it, the ability to transfer knowledge to people in the future becomes greatly limited. So if there's a way to get it in the kernel, that's a great way to make sure that you're really enabling other people moving forward. And then we have a great developer community, including folks like the folks at JPL. This is a prototype of their Mars rover that they were running underneath the Arctic ice, running on a Beaglebone Black. It's just not always news. I randomly find these things. This was 6 seconds in on a National Geographic special, and never again saw the Beagle. When there was never any mention of Beagle used. But hey, look, that's what they're running it off of.
So was the Beagle developed and tested to become space qualified? I've heard space qualified as a term in the missile lab frequently.
Yep.
Don't know what it means.
Yeah, space qualified really means space tested for the most part. I mean, you can dump a bunch of radiation and characterize things, and that's super, super helpful. But a lot of, if you just put it up into that environment and collect the data, then that's great.
And
the fact is people are really not very forthcoming with a lot of the data. We know it's been up there a bunch of times, and we know people are even putting them in professional satellites. Okay. They're like driving satellites and satellite networks. You want to share back some of that qualification data? We just don't get it. So it's still we aren't organized essentially to produce and provide that characterization information. It's an open hardware development board, people can qualify it and use it the way that they see fit. So we're not set up to do that for the community. Wish we could, it'd be nice. I have talked to a couple people about qualifying the processor for space, but there would have to be a significant business need to justify that. I haven't been able to define that business need.
Okay.
So people use it opportunistically. Even folks like Dremel, right? So the new Dremel laser cutter is controlled by a Seed Studio Beaglebone Green, which is a Beaglebone Black compatible, but it's just a little lower cost because they take the HDMI off. And that's what's used for the real-time control of the laser on the Dremel laser cutter. Now we don't, again, we don't qualify any of this stuff for products. It's an open hardware development board. If you want to use it in a product, well, I mean, I'm not, you have to qualify it and you figure it out. This is the first UL listed laser cutter. As far as I know, the only UL listed laser cutter. And so what's kind of special about our DNA? What makes Beagle different than other development platforms out there? A part of it is our passion is electronics, not just cheap computers. All right. What I care about is that people can actually physically twiddle bits and get excited about what they can do with the physical world in electronics. I'd rather people be learning to make appliances than applications. And what I mean by that is learning to create technology that isn't just like convenient for the technologist, but ultimately convenient for the consumer, right? Technology should be should kind of disappear, right? And it just be more of like an appliance. It just like a toaster does what you want, it makes toast, right? A microwave does what you want, it cooks food. A dishwasher's a nice example of a robot, very, very constrained, right? So if we're building robots to constrain them properly, physically, programmatically, to make them, the technology transparent to the end users. And I'd rather be teaching people the stuff to do that rather than saying, okay, thou shalt connect keyboard, monitor, and mouse, and then, make it look like a computer. No, computer doesn't need to look like a computer, right? It needs to have input, process, output, right? That's what a computer is, what a computer does. So we focus on that input side and the output side. I think we're going to be solving in here a lot of those problems, right? How do I get the input? Processing stuff, well, you've taken the math classes, you figured that out, right? We'll talk a little bit about optimization, I think, tomorrow on image processing, and then the output side. And Linux does a lot to solve that. I'm trying to structure the Beagle project so that it's actually impacting the way the Linux world engages with that physical world. So Linux is kind of our backbone, collaboration is our mantra, and designing things specifically focused on enabling better I/O is what makes us different. So you see lots more I/O pins, right? A lot more peripherals, onboard analog to digital conversion, things like these PRU microcontrollers, which we'll get into. We'll actually try to program some of them today. Try to put a program on. So those things allow you to do really low latency things. So when you're dealing with robotics and mechatronics and physical interfaces, you're not always, like, high-speed number crunching is great, but you're not always worried about just the math. You're worried about the responsiveness, right? The time from input to output. So we'll talk about those microcontrollers that give you that low latency. Robustness. Having onboard flash really helps. The micro SD cards are notoriously failable. The quality is very hard to control. industrial temperature rated boards. So handling that, and a focus on a headless development experience. So again, not starting keyboard, monitor, and mouse, but starting through the web interface, using it like a server instead of a desktop. Like you can use a lot of the Beagles as desktops, but I just generally discourage you, right? It's wasting a lot of cycles that aren't for your purpose of making something. And so we focus on a network-based experience that you can go in bed and put somewhere else, and still work with it in the system. Everything is about collaboration. That's why I'm saying download the very, very latest image, right?